Okay, so here it says linearize the equation into the form y is equals to mx plus c. So we're going to be applying all that we have learned into the physics formula that we see. So this is going to be the decay equation that you will come across in Unit 5. So the way you will work with this is we're going to apply ln on both sides. So ln n is equals to ln n naught e minus lambda t. Okay, and then we're going to do ln n, and then we're going to separate these. So ln n naught plus ln e minus lambda t. Ln e cancels out, this moves front, so we're going to have ln n is equals to ln n naught minus lambda t. So I'm going to rearrange now. So ln n is equals to minus lambda t plus ln n naught. Remember, this is the variable and this is the variable. This is constant and this is constant. So we're going to have y is equals to mx plus c. Next example, we're going to apply ln again, ln q naught e to the power minus t over rc, ln q naught plus ln e to the power minus t over rc. This cancels out, and we're going to be left with something similar again. Okay, now we're going to rearrange. So I'm going to have ln q is equals to minus t. Actually, one second. We're going to have minus 1 over rc here, and then t on the other side, and then we're going to have plus ln q naught. Okay, the reason for that is our t and q are variables, so I need to put them in specific places, and 1 over rc is going to be a constant, and q naught is also a constant, so just be careful with those. So y is equals to mx plus c. So remember the things that are changing, you're going to have to put them on the y and x place, and constant is going to be m and c here. And how do you know what's constant and what's not? That's for you to find out when you go into the chapter, and when we discuss the chapter, you will get to know that. Okay, same thing we have here. We're going to have, I'm going to be a bit quick with this, so it's going to be the same thing. Ln I naught minus t over rc. So ln I minus 1 over rc t plus, one second, ln I naught. So y is equals to mx plus c. Right. Now next example, ln v is equals to ln v naught plus minus t over rc. Ln v is equals to minus 1 over rc t plus ln v naught. So y is equals to mx plus c. So we're going to have something like this, ln v here, t here. The graph will be something like this. The graph gradient is going to be minus 1 over rc, and this is going to be ln v naught. Same thing with all the examples above. For this example also, you're going to have ln n here, you're going to have t here, graph is going to be like this. This is going to be ln n naught, and the gradient will be minus lambda. Okay, so that's all. I hope this is clear. In our last 3 points that I'm going to go through is why linearizing is useful. Now, linearizing an exponential equation makes exponential behavior easier to graph, analyze, and estimate. Next thing is, are there any other equations that we need to linearize besides these in physics? Right, so we went through these, right? Are there any more that we need to know? Yes, in Unit 6, every paper will have a unique equation from an experiment that we'll have to linearize. The constants and variables will be given. So we will come back to this in Unit 6. So anything else you need to know? As far as calculations are concerned, no. However, plotting graphs and entering data into tables, where we use ln and log, that's something that's new. In your paper 6 or Unit 6, you will see this. So we will go through this when we do Unit 6. Okay.